Okay, hello everyone. Welcome to my channel. And in this video, we are discussing about the Leetcode daily challenge problem of 16 September. So basically, this problem name is maximum score for performing multiplication operations, and it is numbered as 1770. So let me show you what the problem is stating. So basically, you are given two integer arrays nums and multipliers of size n and m respectively, where n is greater than equals m. The arrays are one indexed, and you begin with a score of 0, right? And you want to perform exactly m operations, right? On the ith operation, that is first index you are given, you will there are three operations. See, uh, there are two arrays, nums and multipliers, and their size are given. And there is a condition that you can perform any three conditions. These three conditions you have to perform. Like the first condition is that choose one integer x from either the start or the end of the array nums, right? And the second condition is that add multipliers I uh, into x to your score, right? And then after that, we have to remove x from the array nums, right? These three conditions we have to follow. And then after that, we have to return the maximum score after performing m operations, right? So, let me have an example. Let me show you with an example. So basically, this is our array, and let me like show you one thing. We have two arrays, nums and multipliers, that is 3 to 1, and we are let me explain this example. So what we are given, that we are giving two arrays like nums and multipliers, and we have to perform these three operations so that we can return the maximum score after performing m operations. So in this case, our output is 14. So let me just explain you how output is 14 is coming. So basically, we have to play optimally, like obviously in all the questions, like we already do. So what we have to do, right? Let me have like brief introduction how we will proceed. So we are having a nums array and we are having a multipliers array, right? So what in this question we are given that at every time we have to either take the front of the nums or the end of the nums, and we have to multiply it with our ith index of the multiplier, right? So that, and after our multiplier array is exhausted fully, we have to return our score, maximum score we can get, right? So the basic first approach, like you can think of, is a greedy approach. How greedy you will think is that at every time we can just take the maximum of these two. Like we can either take the front and or the end, and we have to multiply it with the ith index of the multiplier, right? So we can take the maximum of the front and the end and multiply it with this, right? And then I can remove the element that I have taken from the nums, and then again repeat the process and take the maximum of the front and the end and multiply with the second index. We are proceeding with the multiplier array, so we will just multiply it with the ith index of the multipliers, and then we can proceed. But see, here the greedy approach will not work, because this is an example. Like this is an example. See, in many examples it may work, but in all the examples it may not work because there is a condition in greedy, right? So let me write, to apply. You all must be knowing that to apply greedy, uh, there must be a continuity. Continuity. How, what is mean by continuity? Is that there is a order, like how our array is proceeding. Like see, for example, I am taking. Let me erase this. May become a problematic problematic word. So there is a I can fixed order, right? So what I am trying to say that see, in let me give an example. So see, in this array. we are given, right? So we can play optimally, we can take the maximum of this and multiply it with this particular thing. But suppose we are taking one thing and we are now proceeding to further, right? Now at the second step we are also doing the same thing, but this may happen at some cases that once we are thinking greedily, after that we are left with no option, and we have to take the worst case in our answer, because there is no fixed order, right? See, it may be decreasing or increasing, like there is no fixed order, like -5, then -3, -3, -2, 7, 1. There is no fixed order, like there is no increasing sequence or decreasing sequence by which we can take our decision. And in also multipliers we have not a fix, like either increasing or decreasing, so that we can like approach, or we can thought of a think process, like there is some increasing process, there is some decreasing process. There is no fixed order, like, right, you are understanding. And we cannot sort these array, because we have to like the basic question is revolving around this, like we have to take the front index or the end index. If I sort this array, so there is no means, like there is no fact of like front and end index, or the index will merge with everyone, so there is no sense in this, right? So what I am thinking here is, so let me think recursively, because greedy will fail here, right? So because there is no fixed order, or there is no like order in which I can think like, okay, this is increasing, so I can think accordingly. This is decreasing, so in the future I will I don't stuck any of the case in which my problem test case will fail, right? So greedy will not work, right? So if greedy is not working, so I can think of recursive function. So how I will think of a recursive function? So like recursive function means what? We can like make all the recursive calls. Like we can just analyze all the like possibilities that may arise, like in doing the problem. So what I can do is that, see, there are two conditions that are given, right? So this is my nums and this is my multipliers array. So how I write recursion? So let me have a deep down on itself. See, there are two options. Either we can take front, or either we can take back from the nums array, right? So what I will do, I can take a int start, like start variable that points to starting index of the nums, and I can take a end variable that points to the ending index of the nums, right? And at every case, we have two options. So we have two options. Either we can like take the first starting element of the nums and multiply it with the multipliers I. So we have a front. Let me call it as front option. So in this, what we are doing is that we will just multiply of nums of start with the multipliers of like I. This is a, see, multipliers is an array in which we traverse in only one direction, right? At every case we will just decide these two elements which I can take and multiply it with this, and then after that I will remove that element that I have taken. Now I will again perform recursion on that, and I will move on to index the next index, right? So if I take the front element, I will like add this to my answer, and I will call the recursive call. Let me have a function known as f. So I will call a function with my I is incremented by 1, and if I taking s, so s will incremented by 1, and the function call will continue, right? And n will remain as it is, right? And if I take the second, like the last element, so my let me call it as real. So I will take the nums of like end and multiply it with multipliers multipliers of basically I, right? And I will just then call a recursive function. Like I will always increment my I with 1, because I am making a call. And in this case, my s does not change, and it is reduced by 1, right? So this is my two recursive. These are my two recursive calls, and at the end, I will just return the max, because I have to return the maximum value I can get. So I can return the front and rear, right? So all about the recursive code. And what is the base case here? So the base case here is like, see, we like the nums array may have size greater than the multipliers, right? And we have to basically we are given that we have to traverse on multipliers array, right? So what is the size of the multipliers array? So once we started I from here, and once we have exhausted multipliers array, so we can just return from there, and we don't have to proceed further because we only have to traverse over the multipliers array basically. So base case is when my I reaches m, where m is the size of multipliers array, I return. This is the base case. And now see, right? So these are the basically this is the basic recursive code. And one thing, like we are having three variables changing here, I, S, and E. So see, I will show you one recursive like tree, how the proceedings will go, and how are the overlapping problems are there. So we are trying to applying a DP in the further steps. So we are assuming that there are three variables changing I, S, and D. So if we are applying a DP vector, so we are required to make a 3D vector, which is of course not a better idea here. So because it will just take a large memory. So like think of some other way, like how we can eliminate the like E end array, the end the index. So how we can eliminate this? And like I can is there any possibility like I can eliminate uh, E array and just make it in the form of I and S? So yeah, there is a possibility. Let me show you how. So basically, what is end? So end is basically pointing to the the index which I am from the end of the nums array which I am taking or not, right? So suppose uh, I have my I and I have my S. So how what the I denotes? I basically denotes like how many elements I have taken, like right? So suppose I have taken my five elements into consideration. Let me call it as six. Suppose any random, right? Eight. And my S suppose pointing to it is pointing to four, right? Let me have I as 8 and S as 2. So what it is denoting that I have taken 8 elements into consideration. I have move on to 8 elements, and I have taken 2 elements from the start. So like it is pretty much of course how many elements I have taken from the end to have my processing till here. So to I will have to take the end. I have taken like I minus S elements from the end to proceed to this condition, right? So these are the number of elements I have taken. And to denote the condition to index, like this is a like one based index we are given. So what I have do, but in the array we are always following a zero based indexing. So what I will do, I will just decrement it by -1 so that I can put in my array. So basically I can and this is basically the number of elements I have taken. And how I can calculate the index? I minus S is the number of elements I have taken from the end. And to denote the, because we are taking index here, E is the index. So what I can do is that it is equals to nums dot size, in which we are traversing, -1, because we are taking one based indexing, and to like in the array we are always taking zero based index, so that I can put E in my array, so I can decrement it by -1, so it becomes zero based indexing, right? So I can replace E with nums dot size minus I minus S minus 1, right? So like this is the basic condition. Yeah. Right, so this is the condition. So this is all about my algorithm. So let me have a like deep down into the code so that you can understand a bit more clearly. So basically, the code is self-explanatory. So what I have done is we are giving two arrays nums and multipliers. First of all, I calculate n is equals to nums dot size, and then m is equals to multipliers dot size. And now, first of all, forget about this line. I will like this is about the DP. First of all, I will just show about you the recursion. So I have taken int I is equals to 0 and int s is equals to 0. I represent the index like which I am traversing on multipliers array, and s representing the starting array of the nums array, right? Now I will just return a function f. I will make it a int type function that I am passing I s nums multipliers nm and dp, right? Dp is the array. Just forgot about that. I will just discuss about that. So this is our function which return a integer type, right? So first of all, this is a base condition. If my I reaches m, so I will return a 0. So this is our base. One second. So this is our base case. So if my I reaches M, I will return a 0 because like I don't have to take any further processing. So like forget about this line of, first of all, I will discuss it later on. So after that, what I will do, I have two options. Either I can take like multipliers, either I can take from front, and these conditions are similar to that. But instead of E, I have written the this condition where nums dot size is basically n. We are given n, right? Only see, I have like eliminated this end from here, and the rest thing are same. In front is equal to if I take front, I will just multipliers I with nums of s plus f. I will call the function with I plus 1 s plus 1 nums multipliers nmdp. And if I take the back one of the like nums, and I will just do like multipliers I with nums of this is all about the end I have discussed, and plus I will call a function with I plus 1. And now I don't like increment my s because I am taking the my end index. And you will be knowing, you will be thinking like if I'm taking an end index, I am not decrementing the, because see this is not necessary, because if I'm taking here s na, so my end will automatically adjust itself according to s I am taking, right? And I am taking nums multipliers nmdp, and after that I will return max of front comma rear, right? So I have made I made a recursive tree of what I am explaining here. So first of all, I start from this is I comma this is I and s. So first of all, like I will move. This is a condition where, see, these are the two conditions. So this condition is all about the front. If I am taking the front element, and this is all about the condition we are taking at rear condition, right? You can I am f00, so I can move on to f11 or f12. See, index always increases because I am traversing over multipliers array. So f11 f10, right? After that, what will it do? It made two recursive calls. Either it is f22 or f21, right? Either it remains same or it incremented. So in this recursive, so first of all, only a one recursive call will made, and like it will return, then the further recursive calls will made. I've just explained you simultaneously, so don't confuse here, right? So this also have two recursive calls, and this also have two recursive calls, and the simultaneously we all have like different recursive calls. And once we have reached I is equals m dot size, I will just return from here, right? So this is all about the like recursive tree here. And like I have made it to like show you the overlapping subproblems here. So you will see that I am making function call of f2 comma 1 here, and I am also making function call of f2 comma 1 here, right? This is one function call I am making here, right? And the other function call is like 3 2 3 2, and 3 1 here, 3 1 here, 3 1 here, 3 2 here, 3 2 also here. So I am making multiple recursive calls that are already been computed. So I will have multiple overlapping conditions. So I will use here the DP approach. And how I am using the DP approach, I am using the memoization approach here to like to basically store the values that are already being computed. So what I have done is I made a vector of DP, And what is the size here? This is the m plus 1 and m plus 1. Why this is m plus 1, m plus 1? Because we are having two changing variables. One is I and one is s. So I can range from like 0 to like this index, like the end of the array, that multipliers array, because I am traversing I over here. And so it is basically maximum size is m and one base index. So I will take as m plus 1, and start also varies from 0 to the size of the multipliers array, because I basically I am doing my processing on multipliers array, right? So I am taking this, right, and I am initializing with int min. Why I'm not initializing with -1? Because -1 is already there, right? -1 will because these have negative values also, so it may happen that -1 is already being something, and it may cause some test case error. So I will take that element, that value that cannot exist in nums and multipliers, right? So I have taken -1 and I am getting an error. So I am taking so I will take int min, so that the value is not present anywhere, so that I may not the like code does not fail anywhere, right? And after that I have like call dp over here, and the main function vector of int address of dp, vector of vector int address dp, because I am taking dp as my address. So I am what I will do now, I will, when I am returning the like value, I will just store the value of that in dp I comma s, and I first I will check that if my dp of I comma s is not equals to int min, so I will just return dp of I minus is, so that if this is already being computed, so I don't have to like go into the recursive calls, and I will just return from here. So this is about the memoization code. I hope like you understand this code pretty much well. So let me just like run this code. So yeah, this is working. So I hope you like understand this code, and if you like this video, you may hit a like button and like share among your friends, and subscribe to the channel, and I will see you in the next video. Till then, stay safe and take care. Bye bye.